Okay, cool. We talked about the little game that's going. It looks like we had some people join, so I won't spend a bunch of time there. My name's Brian. I'm the engineering manager over at Elephant. You see a lot of us because Caden's our fearless co-founder and architect over at Ask Elephant, and he helps manage this thing. I won't spend too much time there. I have a ton of content. I trimmed it down a bunch, so I'm going to try to move pretty quick. And then if you guys have questions, I'm going to stay pretty high level too because of that. But if you guys want to chat after about like some of the technical stuff that's behind it, then I'm happy to do that too. What this talk is as an engineering manager for an AI company that is also trying to push the boundaries of AI development, we succeeded at doing that. We took quite a journey, but then I wanted to take like a retrospective of kind of how that worked out and the effects that it had. So I'm gonna run through really quick of our journey. So the journey into AI starts the same way for everybody, right? Tab complete, you're like, holy cow, that just wrote that function for me. And then we get involved. That was basically the start even for us initially. And then we get into AI assisted coding. And this is what I would describe just to like set up terms. AI assisted coding, I think, is where you're like still doing the engineering, but you might have like the chat on the side and you're like, okay, I'm in this file, can you write this function that does this? And then you're like directing it at each step. I would think of this a lot like if you were like training a junior engineer and you're gonna code with them and kind of just walk them through what they're doing. And then the first big step into automation that we took to push the boundaries was getting to full ticket automation. So for me, this was a huge trust boundary, and it took me a while to get over. But I realized like the path that I had chosen to be in an AI company, I had to figure out how to get to a point where I could hand over automating an entire ticket to AI. Kind of what you were alluding to, like how do you do that? And I certainly didn't have the trust to begin with. So my solution to that was, if I don't trust AI to do it, then I'm going to be an engineer and I'm going to build a whole workflow around AI until I do trust it. So I built this whole flow. I'm not going to go into the details, like I said. We can talk about it after if you guys are interested. But it has these steps: research, plan, execution, finalization, PR creation, and then a persistent review. For me, as a manager in engineering, I see a lot of managers who try to be a code contributor and a manager, and I've never felt like you could do a good job of both of those. So one of my motivations for building this automation was that maybe I could do that, because if I automated the code contributions, then I could have enough time to actually be a good engineering manager instead of having to split that time and just doing a terrible job at both of those. And then the other big one is what you alluded to too, is that we already started to introduce things like CodeRabbit for code reviews. I don't think we had Codex yet at the time. But when you got these AI reviews, you'd go through, you'd fix the comments, you'd push up the fixes, they would run again, and you get more comments. And the cycle of like trying to compete with the code reviews from AI was a nightmare. So I was like, hey, we're going automation. I automated that leg. In fact, the bottom is kind of where this started. Like, how do I automate some of this? Like, it triages to see if some of the comments are just garbage, because we know some of the AI code review comments are like just off scope. They don't have anything to do with it. And then work on the ones that do, and I could monitor, and it kept a record. The embarrassing thing behind this is when I first started building this, I was just exploring the Ralph Wiggum model you guys have probably heard of, that Joffrey Huntley made. And I built it into a CLI tool, and I hadn't planned for it to be adopted, and so I just called it Ralph for, I didn't, just a placeholder. And it took adoption so fast I never got to change the name. So forevermore, if you listen to engineering talking, they were mentioning Ralph all the time, which just I found kind of embarrassing the whole time, to be honest. This was the key to Pandora's box, though, for us. So like we wanted to push the envelope. You had all these tweets going out. They're like, oh yeah, like we're doing the night shift. We don't even write code anymore. We're pushing 20,000 PRs, like all the hype that you saw. But like, we're pushing the boundary too. So let's see where we're gonna take this thing. So we jumped into full automation. So the first thing is like 10x engineer, right? Like that's the goal. AI, we're all 10x engineers after that. And there was a lot that was offered to that. We could have a smaller engineering team. You could do parallel lanes. I ended up at one point having 7 clones of our repo, so I could have like all these different things happening simultaneously. Test coverage was almost 100%. PR volume was through the roof. You could iterate fast. You could experiment cheap. You could fail fast. Shorter time to delivery, the 10x engineer dream, right? And then Product-driven cloud agents was the next. So we just escalate because that was the goal. Like we're pushing the boundary. We knew we were going to push it too far, but again, that's the goal. We're an AI company. You can't really find the line, right? Like unless you step past it every once in a while to know where it is. The product-driven cloud agent. So the theory behind this one is that a lot of time is wasted in engineering, where you have product goes and does the research, they know what they want, they can disseminate that to engineering at a high level, but then there's the critiques. Like you meet with customers, you gotta tune the UI, you gotta make small incremental changes. Why do engineers need to be involved in that at all, is the thought, right? So if we could make it accessible to non-engineers to contribute to code, then that would be awesome. So Cursor Cloud Agents was the answer to that. We packaged up the app, got it ready to where we could push to the cloud agents, and then through the automation that we were already using, we were already building up, and we were already improving all the time, we could do these small changes. And there was a lot of effect behind that, because if you go through and you're like, oh, I got to just rearrange this from this to this or change the text or something, there's no reason really to have an engineer do that by hand when you have an automated process that can basically do a more complicated engineering ticket already. CS contribution pipeline. So they're like, okay, let's go even farther. So we set up a Slack channel where CS reps could get complaints or improvement requests. We could triage those with some human intervention, and then they could put in descriptions into the Slack channel that could automatically kick off research, create a ticket, and we already have the automation pipeline. So plug into that. And then one of our engineers built a orchestration layer over the top of that, so he could run a lot of tickets simultaneously. And once you're on cloud agents, you can scale horizontally all you want all day long. And then automated bug fixes is pretty simple. Like you can watch the logs now in your cloud infrastructure, look for new errors that come up, and then do all the same thing. It's all the same pieces. It's like Taco Bell, right? Like you just keep remixing the ingredients. You just have it kick off the research. You have it create the ticket, kick the ticket off to automation, and it lands in code review for engineering to make sure that it's not garbage coming through. And then exactly the same automated CVE remediation. I don't know if you guys have noticed lately, but there are a lot of CVEs lately. I've jokingly say this, but I actually kind of believe it, that there is no permutation of your app's dependencies that are vulnerability free. So you just have to keep moving forward and trying to stay ahead of the ones that are being exploited, because the exploits are just coming out so fast now. It's like, is there like a fully compatible version of your app where all dependencies are free of CVEs? It's like almost impossible. It's crazy how much goes. So this was really helpful to automate some of that, because that's like a full-time job now, just trying to keep yourself versioned out of vulnerabilities within your dependencies. Okay, that's all the cool stuff. I could end right there, and then I could put out a sweet LinkedIn post about how awesome our company is and how many PRs we did. I could jump on X and brag about all those numbers. But that's not what I want to talk about. You've heard all that hype before. I just wanted to show that like the things that I'm talking about are coming from experience. We did push it really far, but there are some legitimate concerns. So first is like, what is this doing to the code? At some point, it's time to put your hand on the pulse and be like, what is happening with this? And then the big concern for me, being a manager, is what's happening to my engineers. Like, are we healthy? Are we happy? Like, what's happening there? So the first thing I want to talk about is the engineers. So this is the way I've described it before, and Palmer kind of covered this a little bit, but the application layer, you've got like product, infrastructure, some of us got to contribute to architecture. You might do open source for libraries, but basically in the code in the application layer is where our passions lie. Like if you're a software engineer, you fell in love with the complexity of code, you get to play with the architecture a little bit, or if you're an architect, you get to spend more time there. But we love that, right? Like there was a time when I would actually spend a bit of time thinking like, should I multi-line this, or should I put it all in one line? Like, do I want it, like, is it too compact? What's the next engineer that reads this gonna think of it, let it be able to understand it? And I frankly miss that. Like that was something I really enjoyed, and I think all of us did. And then AI comes along, and it's like, we have to spend so much time at orchestration level that the question I would pose when we're talking about it with the engineers is, if you have to give up the application layer, if that's not what you own anymore, if the code isn't what you own, but you have to move up into this new layer that's like half architecture, but it's also like a whole new thing where you're like orchestrating automations and you have to wrangle all these AI agents, The question is like, can you find fulfillment here? And most people can't easily answer that question, and some people can just not say yes to that ever. And that's like the sad thing that was like a little bit hard to confront as I was exploring this in AI. Like, in fact, even posing this questions invoked an emotional response sometime because everybody kind of knew that was happening, but it's like, can we hang on to it? Like, do we have to go down this road? Even though it's super exciting to see like what we're doing, we're pushing the boundary, we're competing with these crazy tweets, and we're pumping out PRs. Non-engineers are just contributing. It's super cool, but are you fulfilled there? Like, is that doing it for you? Like that thing that made you become a software engineer, is it still there for you? And then on top of that, it's like, how do new engineers develop their coding skills in this space? And how do more experienced engineers avoid losing their skills? I remember talking to one of my engineers who was asking me this, trying to grow in their career, and I like just straight up didn't have an answer for him. So a lot of what I'm talking about is me endeavoring to answer that because I didn't know what it was. I did a bunch of research. I even kicked off some like deep research, so I went obviously go back to AI again because that streamlines the research too. And the conclusion that I came up with is you can't. If you exit the code layer completely, you will atrophy and you can't really grow in that space if you never gain that experience. That's a hard thing to deal with when you're being pressured by your company, maybe. Like everybody comes from a different organization, so I don't know what it is, but like as an engineer, you feel the wave coming and you're like, I gotta make my career valid tomorrow, right? I gotta keep up with this. So you might push yourself, your company might be pushing you. And then you're faced with that question, and you got to decide like, how do I grow? Like, how much do I commit to this? Am I going to survive if I try to hold back to grow my skills? Like, are those skills going to be valid? Like, what do I do, right? There's this video that one of my engineers also sent me from a guy. I hadn't seen him before. His name's Mo Batar, but the title of it, and it's a good watch. It's really short. Is I was a 10x engineer and now I'm useless. And he kind of just like talks about he obviously owned his own application that he was designing and building, and just realizing that like like what do I do now that I've gone through AI? So here's some quotes from him. He says, AI has completely one-shotted my ability to code. It's impossible to keep up with the AIs trying to understand every line. And then everything works, it's there, but I have no idea who I am anymore in the process. By the end of the video, he kind of just like decides to delete cursor because he's like, I got to just get out of it for a minute. Kind of just like a live existential crisis, but it's honest, and I enjoy watching something like that. One of the aspects of it, you may have noticed with all the velocity I mentioned, that there's one point in the funnel, code review, and that comes back to engineering. So like you can't just completely not code review, right? Like no matter what your velocity is. So engineers write an engineering ticket, code review comes to you. Ticket automation does it automatically, code review to you. Product cloud agents write it, code review comes to you. CS pipeline, code review comes to you. You can kind of see that this becomes quickly overwhelming. You can't really keep up with that, if we're honest. So you see these people talking about the night shift, the thousands of PRs they're going, but if they're going to come and pretend like anybody knows what's going on with that code and has eyes on it, then I'm going to tell you that they're lying. Unless they just have a huge staff. I guess you could handle it that way too. Because what do? You start letting things through, right? You take some compromises, like they're not huge bugs, nothing is breaking, but the naming, the shape, the pattern, the things I would normally push back on in code review, I'm just going to let those go through. It's not worth it. I don't want to like get lost in the code review cycle. And this hurts as an engineer too, because you had principles when you came into engineering, like you had opinions, like strong opinions loosely held, but now it's strong opinions thrown in the trash because there's no way you can actually honor those, right? But before I go into this one, I think there's a tendency in engineering to kind of just like blame the pressures you're getting from the outside. Like, I have to, like my company wants everything to go AI or whatever it is. As I was looking up some studies, I had a few of these that I decided to pick this one because it showed something that I really want to demonstrate. The Meter did this study back in 2025, so this is a little older. AI models weren't as good. But what they found is that like they forecasted that there would be 20% improvement to their output. Then the developers used it, and afterwards they're like, how much faster do you think you were? And they're like 20%. And then they measured like what actually was produced and estimated it was negative 19% that they produced. Now these numbers aren't important. Old models, things have way improved. I can promise you that at Ask Elephant, so these automations we did produced more than we could have produced without them. It's not really debatable in that space. Quality of every single PR can be talked about. But then they ran a follow-up study in 2026, more recent, and they had to throw out the results. And I apologize, I used AI to create these slides. They're gonna look super AI-y. And it wasn't because of the results of the study, it was because they literally couldn't build a control group. There's a few quotes, I'll just put them up here if you want to read them, but what it boiled down to is that the engineers didn't want to participate in the study because they would have to write code without AI in order to have the comparison, and they didn't want to do it. So they ended up hiding tickets. So if they had like a big ticket that they didn't want to get assigned to don't use AI on this ticket, they would kind of like hide it and just go work on it. And it just like messed up the whole thing, and they couldn't even do the study because engineers didn't want to let go of the AI. So we as engineers were sitting here complaining, oh, code review is too much, like all this and stuff. But like that guy who talked about in the video, it's like a drug. Like you can't just put it down. And we as engineers have to take responsibility for the fact that you are a contributor to the own cage that you're living in, and not just act like you don't want it, because you do. Like, have you like, okay, so we did, this wasn't inspired by this study, so I'm like putting it together for you, but we did the same thing at Ask Elephant. So as an engineering manager, I'm trying to evaluate, how can I actually take care of my engineers? How can they grow? And how can we make sure that we're not getting too much tech debt that we can't get out of? So the first thing I try to do is like, hey guys, I'm going to require you, and this was spoken as a requirement, no consequence, but it was like mandated so that there was no question of whether it was okay. We did 2 PRs a week by hand. When I say by hand, just to clarify the terminology here, I don't mean that like you have to type every keystroke, but like it's that agent-assisted engineering I talked about before. Like that's okay to do, but like you got to get in the code and you should know every line that happens while you're coding. And what do you think that happened? Literally nobody did it. And so I'm like, I've been talking to the engineers. I'm like, sorry, you guys, this is honest moment for those of you who are Ask Elephant. Like we know that we're like having a hard time. It's even an existential crisis, and yet when given the opportunity, nobody takes the opportunity, which was interesting to see. So let's move on to the other question for a sec. Hang on, I'm going to see if I had any other comments I want to make there. Okay, what was this doing to the code? What tech debt were we accumulating? So I mentioned all these things. They're really cool. They're great tweets. They're great LinkedIn posts. The two at the bottom here, automated bug fixes, automated CVE remediation, they came late in the pipeline, and they've just been nothing but good in my opinion. Like it's been a huge win. But these other ones, these that I marked in yellow, like this is where the danger zone started coming from. So like 10x engineering, it's all these things like parallel projects, all that stuff that I mentioned. But a total boost in PRs, 5 or 6 a day from 1 to 2 a day from an engineer. Any engineer can tell you that's a stupid thing to measure, right? Like you're shaking your head before I say that. Like, does he really think that means anything? Well, business leaders do. And if you're honest to yourself, like you might pull up the little analytics page in GitHub sometimes and see like, oh man, we're like really cooking. It's hard to measure engineering, so you take the numbers you can, right? But it's not a good measurement, so there's not really value there. A huge boost in test coverage, just a little out of order, but I want to show you this. This is 100% test coverage with AI. And the funny thing is like, as I was like using AI to make these slides, I didn't even give it this example, but it produced this from what I was describing, and it's like exactly what I was talking about. And then shorter time to product delivery is also questionable. Like as you build up momentum or perceived momentum, you start to realize like how much faster are you delivering? Definitely faster, but not like it looks like you're doing. The problem is that it works. It almost always works, and that makes it hard to argue with. Every ticket that went through had its acceptance criteria met, right? So like, how do you complain about this? You've just done 10 times the PRs you thought. Even engineers don't have to do it. The engineering team is small. You're producing so much, and technically you've delivered everything that you put in a ticket and sent over to automation land. That's the weird thing about AI is like it will, I'll get into more details of this, but it will find a solution. Like if you ask it to do something, it's good enough now, it's going to do that thing, you know, come hell or high water, it's going to find some way to do what you asked, and those acceptance criteria are going to be met. But AI doesn't understand real world architecture. I'm going to share. Okay, let me know if I'm going long and I need to speed up. But a couple things, like examples, is Ivan here. He came to me one day and he's like, "Hey, if you have to do like transformations before you write to the database, he's like, where do you like to put that? Do you like to make that a database responsibility, or do you like to do an application code?" And my answer to that question, it's something I have thought about, is anything that has to do with making sure there's data integrity, I will put into the, I would like the database to handle that. I would like that validation, F keys, whatever you have to do. But anything that's like compute heavy, I would like it into the application layer, because I could basically infinitely scale the application through just spinning up more nodes horizontally. But the database, like, you can only have one write instance, at least for like a Postgres Cloud SQL, and then you have to go into like sharding read replicas and all kinds of nonsense if you get too heavy. So like, you don't want the compute in there, right? AI is not having that conversation. Let me tell you, like, if you have a ticket that's like, hey, I want you to write this piece of data into the database, it is not going to go and think through all that. In fact, we've gone so far, we're an AI company again. And so like handling data, taking extracted data, making sure it's parsed into like discrete scalar values and then saved in a good way is super important. And some of those values are more complex, so they output JSON. And we need to validate those schemas because they came out of AI. So I even went so far as when I was working to put JSON schema validation inside the database in a function that could be called, so that I could make sure that validation happens in there. And it was a conscious trade-off because I knew that was heavy compute. And in fact, we use GCP, and Cloud SQL only has whitelisted extensions that you could add to your Cloud SQL database. And so there's this sweet one that's written in Rust and is super efficient, and we can't have it. So it's like written just manually as a function inside of the database. Not efficient. That was a trade-off. That was like a calculation that somebody who's thinking about, like, what is the outcome way down the road if we don't have this data integrity versus like the efficiency loss that we're doing here. And I can promise you AI is not having that conversation when it's executing tickets that you're generating. That's something that you have to consider about. Another one is source of truth. So like we're a graph first definition shop. So like the GraphQL layer, any enum or whatever, it's defining the graph first, and then you proliferate the types through the application, and that way you stay unified on your types. Well, AI will just never do that, right? Like it will just make up its own type for everything that it writes. So that just flies right out the window. And when I said that like AI will always find a solution, each one of those tickets is successfully executed. The data is written to the database. It probably is valid JSON because there is an application layer that's checking that. And you won't see that issue till way down the road when somebody has to make an update to the database or do a backfill or something outside of that one function. When you break away from your types, then they're not consistent. You won't see that for a long time. And that's the real risk of AI. So one of the big things that's my goal of this talk is I want to equip engineers to talk to engineering leaders to talk to businesses, to like understand the nuances of these things. Because if you just go to your leadership and they are pushing AI and you're like, hey, we got to slow down on this, and you can't like give some of these examples, they're not going to listen to that, right? And hopefully, having gone through the actual experience, the opinions, like this is a very opinionated talk, I'll just admit that, but hopefully having come from experience, they have some value for you. So GitClear did a little bit of a study that shows the results of some of the things that I just described. So code block duplication, up 81%. Error masking constructs, here's a big one. AI always succeeds at the task you give it, but sometimes it just masks things going wrong, and that's how it succeeds, right? And that's going up. Within commit copy paste, duplicating code even within the same commit. Refactors went way down. I was just thinking about this as I was looking at the study. I was like, when was the last time I watched AI decide to do a nice refactor to clean up some code somewhere? Like, no. Have you seen that happen? Cross-file connectivity, it's not aware of the entire architecture. It's very tunnel vision, like Palmer had said before. And then legacy maintenance, I don't really worry about that too much at a new AI tech startup, but it's not refactoring. I like some of the quotes out of this. It's every time you want something, AI creates a new package for it. It's the write-only model and the perpetual V1, which really just hit for me, because that's like the perpetual V1 really describes kind of like the way that it's working. Like it's not reusing, it's not thinking of those things that I just described in deep architecture. So why this happens, this is just, again, opinionated, but something that stands out to me. As a human being, I operate on beliefs, right? So I've gained some experience. I go out, I have a bunch of years of engineering, and then I run into something that just goes terribly wrong, and I figure out why, and I just record this belief of like, I shouldn't do this thing. It results poorly. And then I can just forget about the things that led up to it. I don't remember all the details. This is what can make it frustrating arguing with other human beings, because sometimes they don't remember why they believe the thing that they believe, but there was a reason at some point. Something usually led them there. One of the examples that I have, and I'll try not to spend too much time on all these examples, but I have a belief that you shouldn't use your foreign keys externally, or vice versa, use external IDs as your primary keys in your database. And at like 3 different companies, I've had this conversation where I just could not articulate to someone why they should not do this, but I know it's bad. And now that I've thought about it through for this talk, I can come up with examples, but I won't go deep. I just know, like, don't do that. Like, it's hard to think of the example. You're like, well, it makes sense here, but I just know it's going to go wrong, right? And I don't have to have all the pieces. But AI doesn't work that way at all. It has to have in context. You could tell it your belief, and then it will own that belief like it was its own, right? But you have to decide every single belief to inject into the context window. Whereas a human, you have hundreds of thousands of things that you believe, that you've learned, that you've built, that you know, and you can quickly pull them in as you're navigating through the code and be like, oh, this reminds me of that other thing that went wrong. I'm going to not do that. But AI, unless you thought of it ahead of time and told it that, it's not going to have that belief that you would have put in. Now, obviously, there's training and stuff that goes into the models to make them better that can kind of help with that. But a lot of those things need to be tailored to the application that you're working on. So you're never going to get human level, or at least not anytime soon, in my opinion. I have this analogy, but I think I'll just do it verbally super quickly because I got to go quick here. But this is the way I would kind of describe the way AI acts, is like if I asked my son, I have a 6-year-old son, if I asked him, hey, I need you to take the garbage out to the street, he would probably go and he would take the garbage out to the driveway and put it on the curb where it belongs. That's my son being compliant. If he was maliciously compliant, he'd probably put it in the middle of the road because he technically did what I said, but he's mad at me for some reason. And if he was cooperatively compliant, he might put it on the opposite side of the road because he noticed the garbage truck already drove by on my side of the road. And so he's like actually trying to help me and see the thing done. But AI is indifferently compliant. So I'm not sure why my cursor is not showing up here. So it might go and walk into the end of the driveway and just drop as soon as it hits asphalt. And then you think, okay, well, that's not the right thing. So the way that we do this in automation is we're like, oh, we got to do rules, prompting, agent MDs. So I might have a rule that's like, hey, I want you to put the trash can like exactly right here. And so now it's going to go and put that trash can right there. But then one day somebody parks their car there and it puts it right on top of the car, because AI also weirdly will take what you said as such a mandate that when it doesn't make sense, it will continue to do it anyways, right? So we go and we're like, okay, I'm gonna tell it, or I'm gonna give it a review agent that says like, hey, you got to avoid cars as you go. But then you're having a party or something and you park a couple of cars in the driveway, and your AI agent goes out there and it's like, I have a solution to this problem. I'll just pave another piece of asphalt right here and put the garbage can there. And you're like, holy cow, I never thought of that. It's like, that wasn't the thing that I was gonna do. And it puts the garbage can there instead. So you're like, okay, I don't know what to do here. So you've tried like over prescribing, you've tried these review agents. So eventually you're like, okay, I'm gonna just have all these review agents. I'm gonna explain to it like a garbage truck has to actually be able to reach this. But then what your code review agent ends up doing is just telling it, well, a garbage truck doesn't fit on that piece of asphalt that you made, and it extends the size of the asphalt instead. Like, it just is infinitely creative in doing stupid things, but successfully completing the task. So eventually in automation, we add so many code review bots, we do whatever we can, and the final result is probably that you'll walk out your front door and find out that it's reinvented your trash collection municipality service. It's invented garbage cans that are like a foot wide so it can fit between cars, and done all these stupid things because it's just like, it's going to get the job done, whatever you say. And all of those things, like, this is a funny example, but those are architectural mistakes, that each one of those things that it made, but every time it delivered the task you asked it to. And that's why it's super hard to explain to someone like why something is going awry in your system as you're using AI. So we already learned this. In software, you cannot.
Can I say something really
Yeah,
quick there?
go for it.
Just if you can go back for a second. That just reminded me of what you were saying before about like how, or sorry, yeah, of how it's hard to explain that, especially to like non-engineers, because all they see is that the garbage can got picked up or whatever, or that it got outside.
Yeah.
Right.
Like imagine, so Jason is just commenting that it is indeed hard to explain this because the garbage can did get out there. And even unit tests, like every unit test that said, I executed take garbage out function, did garbage make it to the street? And it might even say to like a truck could come pick it up. Those unit tests are all passing, especially the ones that just asked if the constant you defined was the right shape. But yeah, it's like, but you have to like, feel free to steal the analogy if you think it's funny enough to explain to somebody, but legitimately, like you can only go so far with like trying to predict all this. And we already know that this doesn't work. So in software, you don't like engineering a bridge or something, you fully plan, then you fully execute, and then sometimes you have to go back to planning, but usually that's the idea. But in software, it doesn't work that way. We've already learned it's build, discover, change the plan, and iterate as you go. But for some reason, when it comes to AI, we think we can plan so well that we can set off an automated process to fully execute successfully without flaws at such a velocity that we cannot provide oversight for it. A perfect ticket or perfect prompting is just you trying to do like the perfect waterfall process of having perfectly planned that thing to a degree where it can be fully executed. And you've never done that in your life as a software engineer, where you went and did the thing and you haven't run into something that you had to pivot or adjust or something. That's just not the way it works. What's that? Yeah. So this is kind of the way that I visualize it. I feel like my experience, again, opinionated from my experience, there's this curve that you follow. So I introduce a new automation. I built that system I just showed you guys, and it works pretty good, but I see some flaws. I improve. I add some more prompting. I add some more agent ND files. I add more code review agents. It gets better, and then I start to plateau where I'm like, I just can't quite get what I want out of this. It seems to be messing up. And then as I add more, it just hits critical mass and drops off. Like it's like I should have just left it alone, right? It was like good enough. And then you have this new great idea of how you're going to solve the problem, and you build your next automation to solve it, thinking that you'll do it again. But as silly as this sounds, though, like the plateau was pretty good, right? Like the examples that I gave for Ask Elephant, legitimately, we built an application that works super fast with a small team. Like you can do it. It's not all bad, but you need to be aware of the limitations. Like you will hit a plateau, and it won't do perfect things for you. So if we go back to our little battle, did anybody in this room end up joining? All right, somebody give me a name of your bot. Nobody? Are you embarrassed by it?
Yeah.
All right, I can find one that I know. Oh, where is it?
I can just quit.
I feel like I got to refresh this.
I'm the peon.
Okay, get cooked. So let's look at this. So here's the algorithm. Is this the one? Oh, you know what? I remember I'm gonna have to wander over here. Hang on. The slides I'm using don't actually do what I'm trying to get them to do. Okay. Oh. All right, this is super laggy, so I'm trying to click. There we go. All right, so who's get cooked? Is that you? That's not so bad. Like, what are you embarrassed about? So if you look at this algorithm, it's going to be impressively complex, honestly. Like it's going to do a bunch of math. It'll have like quadratic equations. It's going to be doing sines and cosines for angles. This is pretty impressive. How long did it take you to do this? Like what effort did you put in to create this? Yeah, exactly, right? And it would not make sense, honestly, in this case, and this is kind of what I'm getting at. It would not make sense for him to write this by hand, right? He could, and if he spent a lot of time, he could probably do it better than AI, but it would be like days of like figuring out the right mathematical equations to make stuff happen. Let me ask you something else. there's a timeout to execute this algorithm function. Do you know what it is? There's a timeout to run this. Like, it can only run for so long. What is it? Did you know what it was? It's 12 milliseconds, but yeah. Did you know that you can pass memory between iterations of run, so you could actually track state if you wanted to? Yeah. Actually, Ivan's his Rocket Man one, he went for a totally different approach, and he set up a default set of weights, and then it actually is like training itself as it goes through the cycle. But stuff you just would never know you could do. And I know I'm picking on you, Jason, a little bit, but the point is like AI is super useful for stuff like this. This is impressive to write. And some of the other ones, Hayden over here decided to swing the big hammer and had some extra tokens, so he threw Fable at it, and nobody could beat him. Like, it was crazy. But regardless, let's see if we'll pick up. Okay, cool. Regardless, like, you don't understand the framework around it, not just the code, right? And that's the danger that we get into with AI. Obviously, I set a trap for you with this. Like, it was intended for you to not know the answer to those questions for the sake of the talk. But in reality, too, like, when it's not just that we don't know the code, like, we're not letting go of the code, but if you're not understanding the things that are happening, then if we go back to that other slide and it's like, okay, I don't live at the application level, I live at the architecture level, but you have no idea the interaction between the layers, then you're not a good architect either, right? Like, you're not going to do a good job at that level. The book that Palmer mentioned that we're going through with our book club, right at the beginning, he has this quote. He says, "The greatest limitation to writing software is our ability to understand the systems we are creating." And that's something that we really, I think, we need to focus on in this age of AI. It's not just writing code. You got to understand that at some point. An example of this is one of my engineers. We built this an internal tool, and it used a database called Convex. I don't know if anybody in here has used it. And he had been working there for about a week, and as we were talking, he's like, you know what? I've seen that Convex is in here, but I don't really know what that is, even though I've been using it for over a week through AI. I don't know what is that? I was like, well, I don't know what it is either. I've heard it briefly mentioned in past. So we have this technology that neither of us know about. That kicked off oh, sorry, my slides. That's the trade. Like, you're trading system understanding for velocity, right? So this, and I'll try to wrap up not too long from here, but this kicked off some of the experiments that I did to try to answer those questions that I was posing. So now we've seen like the hype train, what we could post on Twitter or whatever, and then we've seen like the lows of like the results of it. There is a space in between. So experiment 0, I heard him say he doesn't know how to use Convex. I was like, what if I went in there and did that repo and I wrote a ticket against Convex and I did it by hand, which is just something I hadn't done in a while because we were pushing automation so hard. In the space of that one PR that did take significantly longer than it would have if I automated it, I felt like I had a good understanding of what Convex was. Like, in one PR, it was like kind of refreshing. I was like, oh dang, I'm good at this thing. This software engineering, it felt good. It felt good to like stretch my muscles and like get out there and jog again. You know what I mean? Like, it was like a good feeling. And I knew, like, from then on, like, if I had to orchestrate AI to use this tool, I could actually do a good job of it because I know what the heck's going on there. So I set up some experiments at a broader scale. This is probably not chronologically accurate, but for the sake of the illustration, I had an area that I knew I was going to have a revenue leader come in and contribute a ton of code. And this guy's like, you give him a goal and he'll break down any wall to get to it. So in area A that he was going to work in, I hand architected this. I set up all the types, defined custom DSL for these nodes he had to define. Like, I locked this thing down. And then there was another similar model that I needed to implement, but I just told AI, do what I did and follow my from section A, right? And just re-implement it again. I have all the types, like, it's almost the same. In fact, it was simpler. And I turn it over to him, and to my surprise, his goal was 20 PRs a day against these two systems that I built. And he's a revenue guy. This is not an engineer. So I'm like, oh, great. Non-engineers are going to contribute way faster than engineers are. So while he's doing that, then we did another experiment where I asked all the I met with the company. I was like, okay, there's going to be no output from engineering. Talk to product leader, CEO, everything. For tomorrow, you are not allowed to use AI. You have to go in. And again, this is going to be agent assisted engineering. And then I want you to answer these questions. How much have you atrophied? Can you still reason about the code base? What is automated code actually buying us? What bad patterns have snuck in? What tech debt's accumulating? And what is it like in there? Just kind of like gave them a series of questions to be thinking about and then send me their notes. Interestingly enough, even with the entire company having dropped all EPD progress for this day, a few of the engineers still did not do manual coding. I won't mention any names or anything, but what the findings were is atrophy was real. Like you got in there and you're like, what am I doing? Like I don't remember the syntax of stuff. Like it had been a while. Again, this is like where we just pushed the throttle. Code-based knowledge was down. It was unfamiliar. Like it's shifted. Everything's changed since you've been in there. Confidence was low. Like, man, can I get my head wrapped around this? Single focus anxiety was a surprising outcome. You're so used to doing so many things in parallel that when you're given the opportunity to just silence your mind and dig deep into a task, I feel like we've all developed this cron job running in our head that's like, hey, switch tasks. You got to go to the next thing because you're used to like checking all your automations to see if they need your attention. And then there definitely was some bad patterns. I will say though that nothing had exploded. Like again, it's low enough impact that things are still going well. But after the 1 day of coding, the results were actually pretty remarkable. Confidence came back basically at the end of the day. It was like riding a bike. Like the first few strokes were hard, but it was like, oh, I can do this. Same experience that I had had. Understanding returned much faster than it left. It took a lot longer for the AI to go off course than it did for engineers to understand exactly how it went off course and plan for remediation. And then like a few hours of coding was like you saw more stuff than like 30 agent review cycles running against a single PR. It's just so different, but the effect of that experiment was so high. But then the original experiment I told you I kicked off where that guy's going to do 20 PRs against this, the first area that I really prepared for that was fine, to my surprise. Like 2-3 weeks of this, there was a couple things I would do, maybe some rearranging of code, but it wasn't broken. It did exactly what it was designed to do. But the area that I told AI to copy exactly what I had created here just went off the rails. There were some things that it didn't have. AI never voiced like, hey, this is a bad idea, or I need these more functionality. It just totally didn't work. Scrapped is wrong here. AI wrote that, some refactors, but we didn't have to scrap the whole thing. Same tool, same person, same velocity. The big thing that I'm highlighting here is there was 2 like end cap effects that remedied so much that went wrong with AI. It was just simply getting the engineers back into the code and preparing for the fact that you knew that you were going to be doing AI automation in an area. Those 2 things is like, it solved almost everything in those areas. So like things that I would definitely still automate for sure, those bottom ones I showed you, like bug fixes, CVE, remediations. But I'm going to give you like some of my opinions of things that we should do. I think cooldown cycles is a great antidote to this. But let's be honest again in this talk, like we talked about like a lot of the negative things, but AI is not going away. Like we are going this direction in the industry. If maybe you should go like work for some company who's doing like security certificates for airplane networking or something, you might not use AI. But basically anywhere else you go, it's going to be introduced. I feel like I have slides that I thought I got rid of. Oh yeah, introducing cool down cycles. This is one thing that I think works. Prepare for automation sprints, run them, cool down. Like you can really get so much bang for your buck by just getting the engineer back on. And then AI, there's one thing that I'd say here is that that we talked about before, like you have to give up the code layer, you have to give up the application layer. I don't think that that's true. You do have to share it now, though. Like you have to let AI in, but you can't give up ownership of it. You have to still own that. You need to know, like that was a silly example, but you need to know like what the constraints are, what the timeouts are, like what the things that are happening, but you don't have to write the code for it. AI can't design or maintain architecture, but it can read and navigate faster than any of us can. There are some absolute superpowers of AI, and debugging is one of them that we need to be tapping into, and you really shouldn't be like putting the brakes on for these ones, in my opinion. Again, super opinionated talk. If you provide things like an anonymized read replica for your database, sanitized logs, and then read-only scoped infrastructure access, so your agent can go and understand your infrastructure, it can debug. Like we've set this up, and I just like it's crazy how well it debugs stuff. I can be like, hey, with this customer ID, tried to do this thing, it didn't work, and send it off, and it will come back and like have diagnosed everything because it knows the infrastructure, the data, and the logs, and it's like, holy cow, that one, like, really, I would definitely get into that. So this is my conclusion of the talk. I wanted to share that experience so that maybe like some of it could be used to have the conversations between company leadership and engineering leadership. But here's my opinions that come out of it, super opinionated. I think you should pursue automation. I think the learnings that you get from it are going to have a ton of value all by themselves, even if like you don't get to like the holy grail of full automation. Models and tools are going to keep getting better, and some work, like I mentioned, is already ripe for automation. Leaders, I think you need to consider the health of your engineers, not just the output. If your engineers just hate their life because they don't get to exercise their passion at all, and you're going to lose your engineers. That's not going to work well. Don't always reward high output with just heavier work demands. Like, let the wins be enjoyed sometimes. And then trust engineers when they signal for a cool down time. Like, if you can build that relationship, if you can communicate that with your leadership that's driving AI, or yourself if it's just the AI addiction or whatever, then raise that signal and go for it. And then shoot for innovation in this area with actual balance. And then for engineers, own the addiction. Don't just blame everybody else that you have to use AI. Like, you are the problem too. It's a crutch. You get used to convenience, and that's on you too. So when you're given the opportunity to exercise your skills, do it. Find joy in this automation layer. It's not going away. Figure out how to make it a passion and enjoy it. Don't give up ownership. Understand your system. Like, you cannot give up the understanding. And then hit the gym every once in a while. Write code by hand, maybe even turn off tab complete. I actually had to do that when I did my manual coding because the noise of the tab suggestions, when I'm already like, my brain is wired to just jump from AI task to AI task, was like unbearable. And I got to use all those Vim bindings that Palmer was talking about. So, okay, I'm gonna just snapshot this. Let's see if we got our leader that isn't the Ask Elephant person. Looks like, oh yeah, sorry, I have to change this to rounds. So it looks like Peon was, oh yeah. So what you can do just to prove that that's yours, if you can ask your agent to like embed into your algorithm like a Venmo, and then I'll send you $20. I'll just find it in there if that's okay with you. Or you can show me that that's like actually yours. But anyway, that's it. Any questions? We could work it out afterwards.
So obviously, we all are struggling a little bit with, oh yeah, I'm going so fast, turning all this stuff out, that, like you said, there's a little bit of maybe like a systems creep that happens, architecture. And you had said that, that's kind of something that AI doesn't think about automatically.
Mm-hmm.
However, my experience is that if I query, a really frontier model, specifically, let's think about this from a systems design aspect, or I've actually found it really helpful.
Yeah.
To, even helping me think about those questions. I'm curious what.
Yeah, I actually agree with that. But what I think you're doing there is like, you're foreseeing some area of concern that you need to bring into the conversation, and then you're bringing that into the conversation, then AI will do a pretty good job at that. So like, one of the successes that I've had is for the code review, I actually broke up code review into 3 phases, where you have an agent that goes, there's some file globbing too, but an agent that looks through and determines like what things are affected, and then a whole list of like expert code reviewers that have specific concerns. So it's like, you touched an API, this one's actually going to go look up the docs, and that's all it cares about. And then you have a triage agent that takes all of the results of those, their concerns, and then compacts them into like a unified code review. That's worked really well, but inevitably there's like the expert I didn't think of that I need in there, or they disagree with each other or something. So like, I think that's that same graph that I was showing you, where like, you're going up that graph and you can get pretty high, and the plateau is workable, honestly. Like, AI's decent. So I'm not saying like you can't use it, but I don't think you can get to like human level engineering through AI only. If you disagree with that, I'm happy to, like, we get to chat about it too, but that's kind of the way that I see that, if that makes sense. Yeah.
As part of that, Do you have any anti-patterns that you use where you, because like AI so much enables us to do anything and everything. Do you have particular patterns you've built into your AI to say no to things?
That's an interesting one. I'm trying to think of an example. The problem with the negatives with AI is I've also noticed that we'll use like anything that's in context. So in my example of like the garbage can thing, I've definitely found being over prescriptive is like the worst thing that you could do. And negatives is like an aspect of that in my mind. So if you're like, hey, stay away from this, it's gonna like fixate on that thing that it's supposed to stay away from. So I don't usually operate in the negatives. I usually try to have like categorical concerns through like plan review or code review, like I was describing to this gentleman here. Like that works best for me is if you like focus the concerns and then let it breathe, so that if there is some nuance that you're not knowing about, that your plan didn't discover everything, it can be adaptive. Whereas when you over prescribe, I feel like I inevitably end up like forcing it off a cliff.
So to adjust what I was saying, like not no's for the AI, but no's for the people who are making requests of the AI.
I honestly can't think of any. If something pops into my head, I'll
Okay.
tell you. Did you have anything in mind you were?
I just know that sometimes not every customer request or everything that is requested by a customer support person necessarily is a great idea to add to your code base.
Yeah. Oh, yeah. Okay. That's a great one. So we had plans for how to solve some of that, but we just kept humans in the loop for the CS side. So that CS pipeline I described, we kept a CS team for some like aspiring engineers and then people who were just in CS to triage those from like a product perspective first. Because that's a really hard one to do with AI. Because like you talk about architecture is hard, product concerns on top of architecture is like extremely hard to do. So we just used people for that, honestly. Did you have a question over here too?
Oh, I was just gonna ask, so when you have the agents running, how like for their access to the code base, do you just run them in like a multi-root repo where they just see like if you have like 30 repos across like your web app or your backend and everything, where they can see everything, or do they just work like directly?
That's actually something we didn't have to tackle because we use a mono repo.
Okay.
So we kind of sidestepped that concern entirely. I didn't really
Okay.
have to deal
Yeah,
with
because
it.
I was gonna say, for my own work for doing like hardware and firmware and then all the way up the stack, one of the things that was super helpful was just yeah, shove them all together so that he can see like how one change will like propagate the whole pipeline. Like oh, changing like an interface down here will like you get updated in like 30 other spots. So just being able to like get all the
Yeah,
points.
and I think that's the same benefit we get for being a mono repo, but if you have them co-located in code, then you probably get the same effect out of it. We use GCP with Cloud Function and then event-driven architecture, so those event boundaries are very similar to like microservice boundaries, where AI has to intelligently be able to understand that like a cause here will have an effect somewhere else that's not necessarily directly adjacent, but just being located together, I think, yeah, is probably the best solution for that. And then like the HMD files, wherever your entry point is, you can specify some of that architecture to help find those too.
Yeah. Did you publish your the automated workflow that you had for like software development? Is that, I don't know if you said that was on GitHub or that was just like you guys' private thing.
I have not. It's just a internal tool that we've used. I've actually never thought of doing that, to be honest.
Yeah, because we run into the same issue where we have like just like issue ingestion pipelines. And then I have to fan it out to like 10 different code bases and just like try and get everything sorted. So having something that'll like automate the whole process is something I've been like.
Yeah, I'm happy to chat about kind of some of the techniques that I used. Ours is definitely built like for our repo and has a lot of it's very fine-tuned for our repo, so I wouldn't really port easily. But do you need me to stop, Kate, or are you
No,
just sneaking around? Okay.
So you kind of touched on this with like it was touched on a little bit with the code review process. I feel like the bottleneck has moved from, ticket generation and engineers, but then now we have these code reviews that are coming in and they're coming in at rapid pace. And as an engineer, like today I saw a PR with 191 files changed and I was like, I just glossed over and was like, there's no way, like I'm not looking at every change. But we still have to maintain some level of ownership over the code. How
Yeah.
do we, maybe I'm looking for advice on how to navigate, like, especially from an individual contributor level, how do we encourage AI use and embrace it, but also advocate for not getting past PRs with 200 files changed?
Yeah, that's a tough one because the bottleneck, like it's got to go through code review. Like somebody's got to get eyes on it. And if you're overwhelmed, then your eyes aren't on it, even if you pretend that they are. To be honest, like some of the most extremes I just described is not like normal operating. That was like testing the boundaries. So we've definitely dialed back on that. But there's a threshold you just can't pass, and it's just human perception. And I'm not even talking about code review, but just if a system changes faster than you can understand the change, regardless of code, even if it was just described to you at high level, then you can't possibly have those eyes on. It's just impossible. And I think you have to. That's the hard conversation that sometimes you have to have with whoever's like pushing the automation, is like, this is literally impossible. I know like there's the AI hype and stuff, and that may be acceptable, like to accept the impossibility, because if you are a tech startup and you're like, we want to just beat someone to this feature and I don't care if it's architectural trash, get me there, do it. Like go for it, right? Like that's a use case. And sometimes you have to do that, especially if you're in the AI space. But if you're actually trying to build something that has longevity to it, you cannot move faster than the human perception of the changing system that they have to own. Otherwise, you will have architectural drift and your application will start to pay that price later. And it happens very slow with AI because none of the PRs are going to give you catastrophic failure, but you'll start to have query inefficiencies. You'll start to have wonky behavior that becomes increasingly difficult to describe because your application's complexity has just ballooned because nobody had an eye on it. And we as engineers, if like that's the system you're building and it needs to be secure, it needs to live for a long time, and you're not okay scrapping it and recreating it after you've done some kind of POC phase, you have to communicate that because it will happen and you can't stop it if nobody has eyes on it. That's super opinionated, but that's my belief in that.
I would also add that a lot of the problems that we see with AI, like these bottlenecks and problems like massive PRs, have been problems before AI. And we had ways to solve those problems before AI, which was creating cultural rules in your org as to like PRs larger than a certain amount need to be broken up into smaller pieces, right? Like there's been times in my career pre-AI where I've had PRs literally just blocked at code review where they're like, this is too much, break it up into smaller pieces, and they won't look at it otherwise until it's like broken up into smaller pieces for a person to actually look at. And it's like, you can add those same cultural aspects to your org if you want to. And if your team is like on board, so like if you're not the only one feeling that way, then like your team should talk about that. You should talk about like, what are we supposed to do in these kinds of situations? Like, how do we want to handle this? Like, are we okay with like rubber stamping something like this? And I can guarantee most of your team's probably gonna be like, no, not really. So then you as a team can talk about like what things should you guys do differently to handle that like the way you would want to as a team. So
Yeah.
Thank you. I also wanted to ask about the code reviews. I get where you're coming from, but I wonder, have you considered other ways for sharing that context, for getting the information across about what has changed besides a pull request? Like, it just strikes me that, again, and I don't have an opinion, I'm not trying to argue a side, but like could be other ways to communicate, like these are the things that are changing in the code. There could be other ways to surface problems. I mean, you could like invest really heavily on end-to-end testing and, look at it from a product perspective, or I don't know, I could make things up. You could have AI like build you a video running you through the changes or something like.
Yeah.
So why is it that you decided this is the place where humans will gather the context of what is changing?
Yeah, I actually 100% agree with you. I think that tooling will continue to advance, and those are some tools that we need. I think we're using a lot of old constructs like regular PR reviews that need to just adapt and change. But we have to grow into that. I don't think that if you have cool ideas there, then you should invent that. And but what I was having like that strong statement opinion about wasn't necessarily like specifically code review even, is what I meant by like understanding the change of system is like putting the code review aside. If you can't have it even like described to you, like, oh, we re-architected this and it works this way now, and then someone over here is like, oh, but we changed this, and that noise is like happening faster than you could comprehend, or at least the owners of a particular area of your code, then that's like the human comprehension speed limit that I think has to exist, not necessarily the code review itself. Because let's be honest, like we do care less about the code, right? Like when I described, like, should I multi-line this so it's more readable, or would like a ternary function or a if statement be better and one line it? Like we probably just have to let that stuff go, honestly, and you're not going to call that out in code review anymore, and that's going to streamline some of your code review. But you still have to understand like the architectural impact of the things that you're doing. If you violated like the persistence of the types and their source of truth, like those things have to be guarded. And I agree that there should be better, we need better tools for that. And some of the automation that I did is actually had my agents go and reviewing things, kicking off review specialist agents for that, and then giving me reports on like the things I should put my attention to. But even that, like, it's just not ready. It couldn't do well enough of understanding the architecture to always highlight the right thing. So that's kind of, it has more to do with just like the pace of the change of system outpacing your understanding of the system more than the actual code review. And I absolutely believe that tools will get better at disseminating that information and packaging it in a way that humans can process more quickly. But I still think that's like a speed limit we should respect, even if it's incremental. Like you sprint and you don't know what the heck happened, but you have dedicated time to go back and then retroactively understand it so that then you can compensate or adjust things going forward. You got to do something though, I think.